And welcome back, students. As we dive into more on interclasses, let's today look at some simple uses of interclasses by first talking about that of helping classes. So getting started, interclasses are classes that are defined within other classes. So in this lesson, we're going to describe one of the most useful application of interclasses, namely interclasses as helping classes. This is going to be very similar to kind of how we worked with helping methods. We're automatically going to know some similarities, particularly in the access levels between public and private. So when we talk about inter and outer classes, defining an interclass is pretty straightforward. We simply include the definition of the inner class within another class, kind of like as follows. So we'll have a public class, outer class, just like we always will. And then inside of that, you'll have a private class, inner class. You'll have your declarations of any instance variables, the definitions of any interclass methods. You'll close that, and then you'll do your normal class for the outer class, instance variables, and outer class methods. So as this outline suggests, the class that includes the inner class is called an outer class. The definition of an inner class or classes need not be the first items of the outer class, but is a good place to either place it first or last so it's easy to find. So you can technically place that inner class anywhere within the outer class. You'll be okay. But it's good practice to put it at the beginning or at the end. Now, I'm going to put mine at the beginning simply because that's just an easier place to find it then. Now, the inner class does not actually need to be private, right? But we're going to start with that case in this lesson, all right? So later on, we can look at what happens when we look at public inner classes, but right now, let's just stick to private. We will look at those other methods later on, but for now, again, we're just looking at private because it's the easiest way to start. Now, interclass definition is a member of the outer class in the same way that the instance variables of the outer class and methods of the outer class are members of that outer class. Therefore, or thus, if you will, an interclass definition is local to that of the outer class definition. So you can reuse the name of the inner class for something else outside the definition of the outer class. Now, if the interclass is private, as ours will always be in this lesson, then the interclass cannot be accessed by name outside the definition of the outer class. So there's two big advantages for us using interclasses versus, like, let's say, creating their own independent classes. All right, first, because they're defined within a class, they can be used to make the outer class self-contained, or relatively more self-contained than otherwise would be. You don't have to have like a different set of classes, and stuff like that, because it's all within that class. Second, the inner and outer classes methods have access to each other's private methods and private instance variables. So this can be advantageous if you need to somehow access those without trying to worry about juggling different objects. So here's a tip when you're dealing with inner and outer classes. They have access to each other's private members. And when we say members, we're talking about their variables and their methods here. So within the definition of a method of inner class, it's legal to reference a private instance variable of the outer class and invoke a private method of the outer class. So to facilitate this, Java follows this convention. If a method is invoked in an inner class and the inner class has no such method, then it is assumed to be an invocation of the method by the name of the outer class. If the outer class also has a method, no method by the name, then of course obviously it's an error. All right, it's like this method just doesn't exist. Similarly, an inner class can use the name of instance variable of the outer class. Now the reverse situation though, invoking a method of the inner class from the outer class, not quite so simple. To invoke a non-static method of the inner class from within the outer class, you need an object of the inner class to use as a calling object, such as we will do in our class bank account. And I'll look at that in just a minute here. As long as you're within the definition of either the inner or the outer class, the modifiers public and private used within the inner or outer classes are equivalent. Now these sorts of invocations and variable references that cross between inner and outer classes can get confusing. So it is best to confine such invocations and variable references to cases that are relatively clear and straightforward. So you don't always have to try to make it an inner class or an outer class. Now it's easy to tie your code in knots or get confused if you get carried away with this sort of thing. All right, so it's not necessarily a be-all end-all solution that you should always be programming this way. So let's look at our example now with a bank account class. Now, a bank account contains a very simplified bank account program with an inner class for amounts of money. The bank account uses values of type string to obtain and return amounts of money, such as the amount of a deposit or the answer to a query for the account balance. However, Inside the class, it stores the amounts of money as type money, which is an inner class. Values of type money are not stored as strings, which of course would be difficult to do math on, nor are they as value of type double, which you can actually run into round off errors, right? Which is unacceptable, making you want your numbers to be as accurate as possible. So, in order to deal with this, the money class stores the money as two integers, one for dollars and one for the cents. In a real banking program, the class money might have a larger collection of methods, such as methods to do addition, subtraction, compute percentages. But in this simple example, we only include the method for adding an amount of money to the calling object. Now, the outer class, bank account, would also have more methods in real class, but here we include only methods to deposit an amount of money to the account and to obtain the account balance. Now, the bank account demo contains a simple demonstration of the program using the class bank account. Now, we'll look again at that in just a second here, but the class money, when we look at that, is a private inner class of the class bank account. So at this point, let's just go here, and right here's our private class money. And you can see it runs all the way down to here. All right, so private class money, and here's our instance variables, here's our methods. For example, here's one that's called money, so it's our constructor. Now, the class money cannot be used outside the class bank account. So if I were to make another class, can't access money, like my bank account demo. Even though it's in the same project, I can't access money because it's a private inner class. Now, public inner classes are discussed in later in the lesson, and they do have some subtleties involved in their use. Now, because the class money is local to the class bank account, the name money can be used for the name of another class outside of the class bank account. This would be true even if money were a public inner class. So technically, I could create another thing called money in the bank account demo, and it'd be okay. Now, we have made the instance variables in the class money private following our usual conventions for class members. Now, when we discuss public inner classes, this point will be important, so just kind of bear that in the back of your mind for the moment. However, for use within the outer class and a private inner class cannot be used anyplace else. There's not really a difference between public and private or other member modifiers. All instance variables and all methods of the inner class are public to the outer class, no matter whether they are marked public or private or anything else. Now, take note of the method closEaccount of the outer class. It uses the private instance variable dollars and cents of the inner class. So if we look at closEaccount, it's all the way down here. So right here it says closEaccount, balance.dollars, balance.cents. You'll notice dollars and cents don't exist here in the outer class, but they do exist here within the inner class. All right, so that wraps up the notes, and let's just go ahead and look at the demo real quick. And you can see the demo is a pretty straight thing. Just says create a new bank account, so it just makes a bank account object called account. It gives you out your balance. Then it says, hey, here's your starting deposit. We're going to put $100 in. So then you call the make deposit method. Then, of course, we say your method is now this. Print out the balance. Rinse and repeat all the way down to we get here when we say closing account. So if we run this, create new account balance is 0, then deposit 100, now 100, 99, 199, 1 cent, 200, closing account balance is now $0 because it's closed. All right. So again, another example that kind of quick and straightforward, but you'll notice, of course, with this one is that in this example, we've only made deposits. So there's nothing in here really to kind of handle withdrawals, for example. All right, but that's going to wrap our lesson up for today, folks. So until the next time.